According to the Big Bang model of the universe, astronomers believe that the expansion of our universe might continue forever or eventually decrease over time, given that there was enough mass and therefore enough self-gravity in the universe to be able to reverse and cause a big crunch. But most cosmologists rejected the idea of the big crunch since data supported evidence of an expanding universe at an ever-slowing rate. But in 1929, Edwin Hubble made a groundbreaking discovery about our universe. He observed that the wavelength of light emitted by distant galaxies shifted to the red end of the electromagnetic spectrum as they traveled through space. He found that the further away a galaxy was from Earth, the larger the redshift in its wavelength. This implied that our universe was not slowing down at all. In fact, it was accelerating. The redshift in further away galaxies showed the wavelength of light must be stretched by the expansion of space itself. So what was causing space to expand? Well, scientists think that there might be a mysterious force behind it called dark energy. Let's look at what we know about dark energy so far. But as always, be sure to subscribe to our channel if you're new here. Dark energy is the name given to the mysterious force that's causing the rate of expansion of our universe to accelerate over time rather than slow down. In this case, dark means unknown rather than literally dark, as is the case with dark matter. Dark energy and dark matter are completely unrelated phenomena. Scientists estimate that dark energy makes up about 68% of the known universe, while dark matter makes up about 27%. Dark energy is one of the greatest unsolved mysteries of cosmology. Similar to dark matter, currently we have no clue on what dark energy is, but we do have a few theories on what it could be. One theory for dark energy says that dark energy may be just a property of empty space. Every second there is new space being created all around us. In fact, wherever there is empty space, there is more space emerging from it. We just don't experience this in our daily lives since we live in a tightly packed cluster of stars in a galaxy held together by gravity. Regardless, space keeps expanding and accelerating. This means that empty space may have more energy than anything else in the universe. So it can generate more space because that is just a property of space which we refer to as dark energy. Again, this is just speculation until we find some solid evidence for it. This idea closely resembles Einstein's idea of cosmological constant, which is a force that opposes the force of gravity. However, measurements of the cosmological constant produce inadmissible results, leading scientists to look elsewhere. Another idea which has gained popularity in recent years is that dark energy resembles a force known as quintessence, which is a relative of the Higgs field. This differs from the cosmological constant explanation of dark energy because of its dynamic nature. So, unlike the cosmological constant, quintessence changes over time. Proponents of this theory believe that quintessence became repulsive about 10 billion years ago, about 3.5 billion years after the Big Bang. But as with any other idea, there is no observational evidence to support or refute this yet. Moreover, some believe that in empty space, random particles continuously spawn out of nothing and then disappear, providing it with the energy to keep expanding. This, they think, could be the reason for dark energy in our universe. So far, no one really knows what dark energy is. All we have right now is theories and speculations. This just goes to show that we have a lot of work cut out for us. So let's get on with it and try to uncover the hidden secrets of the universe. Well, there you have it. This is what we know so far about dark energy. Let us know what you think it might be in the comments down below. Also, don't forget to like, share, and subscribe to our channel. Until then, we'll see you in the next one.